You know, our bodies have this incredible way of leaving clues behind, little fingerprints that tell a story. Today, we're going on a bit of a detective mission to look at one of those clues. It's called hemosiderosis, and it's a story written in iron. Let's get into it.
So our whole investigation really boils down to one simple question. What can a change in color, like a really basic color change in our organs, actually tell us? Turns out it can reveal a whole story about our health, our history, and what's really going on deep inside our bodies.
All right, let's get into the investigation. We're going to start with the first piece of evidence, a very telltale color change.
I want you to picture this. A pathologist is looking at an organ. Could be a lung, could be a liver, but instead of its normal, healthy color, it looks rusty, kind of brownish. Now, that's not just some random stain. Nope, it's a message. It's a sign that something has happened here, and that is our number one clue in this whole medical mystery. So, the big question is, what's causing this strange brownish color? It's about time we unmasked the culprit. And here it is. The culprit's name is hemosiderin. It's this amorphous, kind of golden yellow-colored pigment that comes from hemoglobin breaking down. You know, hemoglobin, the protein in our red blood cells that carries all the oxygen around. And that word amorphous just means it's shapeless. This stuff is what's leaving that rusty fingerprint all over our crime scene. Okay, so how does this fingerprint even get left behind? Well, it all starts with some kind of event, right? Maybe a hemorrhage or just a chronic breakdown of old red cells. They spill out of the blood vessels. Immediately, the body's cleanup crew, these amazing cells called macrophages, they swoop in and just gobble up those old cells. Then, inside the macrophage, the hemoglobin is broken down, and its iron gets packed away into these little storage bins called hemosiderin granules. Now, if this happens over and over again, those granules start to pile up, and that's when you can actually see that golden brown pigment. It's incredible, right? A totally microscopic process, creating a clue you can see with your own eyes.
Now, this iron fingerprint can show up in a couple of different ways. First, you have what's called local hemosiderosis. The absolute best example of this is a simple bruise. Think about it. That's a tiny, localized crime scene where blood has leaked and macrophages have left some hemosiderin behind. It's just a marker of a past one-time thing. But then you've got the other side of the coin, systemic hemosiderosis. This is much bigger. It's widespread, affecting organs all over the body. And that points to something chronic, an ongoing issue, like an illness that's constantly breaking down red blood cells, or maybe even the result of getting lots of blood transfusions.
To really understand just how powerful this clue is for making a diagnosis, we have to look at a classic case file. So we're heading to the lungs, because there we can find a piece of evidence so specific, it's pretty much a smoking gun. So here's the setup. When someone has chronic left-sided heart failure, their heart just can't pump blood out to the rest of the body effectively. This creates a massive traffic jam, and blood starts backing up right into the vessels of the lungs. The pressure builds and builds until red blood cells are literally squeezed out of the tiny capillaries and into the lungs' air sacs, where they definitely don't belong. And you know what happens when red blood cells are somewhere they shouldn't be, right? The macrophage cleanup crew arrives on the scene. And these macrophages in the lungs get so stuffed with hemosiderin that they actually get a special name: heart failure cells. Finding these under a microscope is a direct, undeniable confirmation of chronic lung congestion, which is almost always caused by heart failure. It's a perfect diagnostic clue.
And hey, the lungs aren't the only place pathologists find this stuff. There are other common crime scenes. In the lungs, we already know the buildup can lead to what's called brown induration. And induration is just a medical term for hardening. In the liver, chronic congestion creates a very distinct nutmeg pattern. And the spleen, it can become dark red and firm. Each of these patterns is a different clue that tells a story of chronic congestion.
Okay, so we've identified our culprit, we've seen how it operates, and we've visited the crime scenes. Now it's time for the most important part. What does all of this evidence really mean for a diagnosis?
This brings us to a really important question, and it's a point of confusion for a lot of people. We've seen all these effects of the pigment building up. So is hemosiderosis itself the disease we should be worried about?
And the answer is a firm no. Absolutely not. Hemosiderosis is the clue. It's the fingerprint left at the scene. The condition, something like chronic heart failure, is the underlying cause, the real problem. The clue just points doctors in the right direction. And honestly, this is the most important takeaway here. You don't treat the clue, you treat the condition that's causing it. And of course, pathologists have to distinguish this iron fingerprint from other suspects. For example, hemosiderosis is very different from hemochromatosis, which is a much more serious condition where the iron overload is actually causing organ damage. It's also totally different from other pigments like melanin, which gives our skin its color, or anthracosis, which is just black carbon pigment from inhaled dust. Each one tells a totally different story.
So, let's bring it all together. The crucial point here is that hemosiderosis isn't the villain of the story. It's the key witness. It acts as a vital diagnostic marker that gives us a physical, visible record of past events, everything from a single hemorrhage to a long-running chronic disease. It's history, written in iron, right inside our own cells.
Finding a whole story in something as simple as a color change, it really makes you wonder, doesn't it? It leaves us with a final thought. What other hidden messages, what other secret histories are written in the incredible landscape of our cells, just waiting for us to learn how to read them?